What's going on, guys? Ishin here from CZeroMedia. In today's episode, I'm just gonna say right away that by the end of this episode, you're gonna learn a thing or two or 100 different things about building Evo engines. So long story short, you guys all know that I went to Mod 2018 Mitsubishi Owners Day over in Los Angeles, California. I was walking around the event, filming, doing my own thing, and the guys at JRP Performance noticed me. The two owners, Jeffery and Roni, they noticed me. They're like, CZeroMedia, holy shit, like I've been watching your videos for so many years. I'm a huge fan of you. I've been watching your videos even before I own an Evo. And right there and there, I'm like, holy crap, these guys have been watching my videos even before they own an Evo. And now they have a shop in Los Angeles that is specifically building high horsepower Evos. So I started talking to them, kind of getting to know them, and realized that these are good guys doing good things for the community, doing good work. And I asked them, like, can I come film your shop tomorrow? It was Sunday, the shop was closed, but they said, yes, you're more than welcome to come film the shop, CZeroMedia. They opened the shop up for me on Sunday, even though they're closed. And we literally spent 2 hours filming around the shop, and I probably have like an hour and a half of content, which is full of information, all good information. And because I can't stuff all that in one episode, I'm going to spread into 3 different parts, and this is going to be part 1 of Roni explaining all about Evos, 4G63s, 4B11s, even going into transmissions, GTRs, Lamborghini motors. If you really want to understand how motors are built and what kind of time and energy and engineering goes into it, this is the episode you're gonna want to check out. I'm going to try to answer as many questions as possible in the comment section below, but if I don't get to them, Roni and Jeffery from JRP is gonna be answering that. And if we are overwhelmed with questions in this 1, 2, 3 episode, I'll probably do like a live Q&A session between me, the guys from JRP, and you guys, so we can have a technical Evo discussion. You know, it can be fun, it can be entertaining, but at the same time technical and informative, which is basically the reason why I make these videos, right? I don't want a video where you sit down and watch 20 minutes, at the end of it you're like, what did I learn? I just wasted 20 minutes. It was entertaining, but I didn't learn anything. I don't like videos like that. I want to make sure every video I produce is informative, educational, and that is exactly what this episode is going to be. So that's enough of me talking, guys. I hope you enjoy the footage. I will see you in episode number 2. What's up, guys? This is here from CZeroMedia. Today I'm at JRP Performance, which is Evo specific, I guess GTRs to shop here in LA. I met these guys at Mod Mitsubishi Owners Day. They had a little vendor tent. Met the owners there, and they said, you know what, you should come by and film the shop. You around? Yeah! JRP goodies. I'm gonna have to wear this right now. Alright, guys, now I'm in the shop with Roni. What's going on, guys? And then Jeffery is over there talking to the customers, doing his job, whatnot. But yeah, JRP has been here in LA for about 4 months now. So it's a brand new shop, super clean in here. They got 2 lifts, project cars sitting outside, sitting inside, engine room over here. Let's start with the quick shop tour, huh?
Yeah, for sure.
Yeah.
For sure. This is Jeffrey's car.
Okay.
Okay. Jeffrey, you want to explain about the...
So it's a half tubular front end that we just did, just to shave some weight. We also tack welded the whole engine bay for more frame support.
Yeah.
We also plated it because what happens with Evos is it tends to flex, so we plated it for extra support as well. We're going to be running a Diamond Sport V2 manual rack subframe. I had a Magnus, but I sold it along with you can see right there, it's a Voodoo rear subframe.
Yeah.
I'm trying to break into the 7 seconds by trying to shade everything.
7 seconds.
Yeah, we got
Get ready for something like that, you know?
Yeah.
Yeah. Pretty much trying to shave all the weight we can. This is coming off, doing carbon, getting carbon doors.
Yeah.
Pretty much everything you possibly could think of to a car, we're gonna do it. Ronnie's gonna build the ultimate motor for us. We just ordered our dry sump system.
you know, launching, trying to get the 60 foots down, you don't want to starve the engine of oil because, you know, a split second will basically ruin the motor. So we ended up with the, you know, Magnus dry sump system, and we just basically said we're going to fulfill the block and just use the factory block. This is a standard bore. We're going to a 20 over. We're using 11.5 to 1 compression pistons. Where the water pump bolts up, right? Yep. That's concrete. That's actually cement, right? It's a block filler. So what we do is, to prepare this for that, is we have to clean out all the coolant jackets from all the rust, all the crud and everything that's been, you know, because this has been sitting for a few months. But even if you get it out of a running car, you want to make sure it's as dry as possible, because when you put the, it's called the grut, the concrete thing in there, you want it to adhere to the, you know, to the coolant, to the actual jackets, right, around the cylinder.
Don't want to shoot it.
Exactly. So we filled this. This one's actually 3/4 fill, but we're gonna do a full fill. So the cylinder ends right about here. Yep. So if you were to do a half fill, it would be right here. So it would barely cover this.
Oh, okay.
And what this does is it actually reduces harmonics. Basically supports the bottoms of the cylinder, and it also supports the integrity of the block, you know, obviously. And basically if you have like any flex, you won't end up cracking the block. When you're going this route, obviously you also have to think about the crank and stuff like that. So if you're using a stock crank, you either like cryo treat it, WPC it, or you go with like a billet crank that's been, you know, heat treated a few times. For instance, like the Cali stuff. I'm gonna be running a Cali's billet crank in my car. But those get cryoed, heat treated, and I tried it a few times. So, you know, if you're trying to prevent the block from flexing, you better make sure the crank's not gonna flex, you know? No, yeah, this one's a 3/4 fill, but it's almost a full fill. As you can see, there's, this is where the water pump basically puts water in the motor, right? Yeah. As you can see, there's no way it's gonna put water in the motor now, right? There's this little hole, but that's not gonna be sufficient enough for a water pump trying to, you know, pump water in and out. I mean, that's a very tiny hole. There's a reason why there's 3 giant holes in there. If you're using only one, it's gonna run into issues. So we're like, you know what? We're just gonna full fill it. We're gonna weld the water jackets on the cylinder head, and we're just gonna run an electric water pump. So we're gonna put water through the head and out the head, and we're gonna have an auxiliary mounted water pump. And that's going to take care of the head. And if you have a good enough fan and water pump, you can actually keep the temps quite down. So you might even be able to street drive it. But when you're talking about a car of this magnitude, street driving kind of like gets thrown out the window.
Just in general, right?
Yeah, just in general, man. I mean, you know, just it's going to be so hard to drive this thing on the street. You wouldn't even want to, you know? Yeah. That's when you get another car, another Evo. Yeah, but the best way to do this is a full fill. Yeah. Because if you think about it, the top of the cylinder is where the most support is needed, right? Yeah. Combustion's happening at the top, the most heat's being basically dissipated at the top. Another thing you gotta worry about when you're trying to do this is you have to build the motor looser, because now the cast iron can't expand because there's concrete behind it, right? Yeah. So that's usually only a problem if you're trying to do like a pump gas tune and an E85 tune, which all of these cars are either on methanol or ethanol, right? So it really doesn't matter at that point. But for instance, you would have to add like another thou piston to wall clearance.
I didn't know that.
You know, we build them at about 4,000 piston to wall, the race motors, and all the motors that are like street motors, we build them at 3.5. I have never had an issue with them. We build them pretty tight. You know, good machine work goes a long way. We torque plate every motor. Actually, the high horsepower stuff, we do our own little tricks and stuff. What we do is we actually offset bore the cylinders. What that means is when the piston's at top dead center, right, on the power stroke, when it's trying to go down, we offset the cylinders about 10 to 12 thousandths, right? So we bring it a little this way. Yeah. And what it does is the rod is at less of an angle. So instead of being like this, it's like this. You get what I mean? So it's easier for the rod to go down and make power. So it frees up like a couple horsepower. Huh. We CNC deck it, we CNC bore it, we CNC hone it. I mean, everything's done with like the best equipment. And we pay top dollar for the machine work. But that's kind of the things you have to do to build a motor that's going to last and take abuse. You know? Excuse the mess here.
What are you talking about? It's clean.
We like the king bearings because they don't vary that much in clearance. Like when you get one box of let's say rod bearings and I'm trying to clearance them, very rarely do I have to, you know, get another set to basically end up at the dead on clearances that I want. Versus, you know, other brands you might need like 2-3 sets in order to get to the clearance that you want.
And so let's vote for you 1 year.
Yeah, it's more time efficient.
Yeah.
Makes more sense.
Yeah.
The bearing is super like durable. I have never had a motor go with the bearing. You know, I've never had any rod bearing issues or main bearing issues with Kings. So I just, you know, it's one of those things. If it works, why stop using it? You know. And I actually have this thing. So these are all like the engine building tools we have. You know, we have our dial. Should I pull them out? Should I show you? Or?
Yeah.
Huh?
Why not? Let's get technical.
All right.
Let's get super nerdy in here.
Let's do it. So let's say I want to measure a rod journal on an Evo 8 crank, right? I'll basically open this mic. Sorry. I'll open this mic. I'll basically go on the journal. This is a cam, but you know, you get the idea.
Right.
So I'll make sure I get the air gap out. There's actually a ratchet on here that prevents me from like over tightening it. So all you're trying to do is get the air gap out of there. So at this point I would lock it. I'll take it out. This is a rod vise, by the way. We use this because it's aluminum. So when I'm trying to basically tighten rod bolts and stuff, it doesn't crush the steel.
Oh.
So we put the micrometer in the vise. I'm doing it very lightly. Usually we put something around this because it's a precision tool. You don't want to distort it.
Yeah.
So I'm just trying to
Right, just to
give you
show
guys an idea. Yeah.
Right.
So this is now locked onto the measurement of our cam lobe, right?
Yep.
But let's say it was a crank, right? And now what I would do is I would take the correct size, so the closest size I can get to that from here, the attachment, and I would hook up this is called a dial indicator. I'm just gonna like lightly demonstrate it, right? And then we would put it here, let's say, right? This is not the right size, but I'm just trying to give you an idea.
Right.
And then we would zero this gauge out, so I would basically like move this around until it would stop somewhere, right? And then I would zero it out wherever it would stop.
Right.
And now if I took this and I had my rod here, if I stuck this in the rod, basically the big end of the rod, wherever the gauge would stop, the indicator would stop, it would give me the clearance. Okay.
I see.
So the Mitutoyo stuff is what I use. I use some Fowler stuff too, but the Mitutoyo stuff is more, you know, it's more legitimate. You know, these are made in Japan. Those are made in China. You know. But this goes down to 1/10 of 1,000. So that's the 4th decimal place. So you know, it gets pretty accurate. And you know, when you're using plastic gauge, you're trusting a piece of plastic, literally. You know, and these motors, some people are trying to make 1,000 horsepower. I wouldn't trust a piece of plastic. You know? But yeah, I mean, it takes about 8 to 10 hours, I would say, to assemble the bottom end properly. My machine shop basically does all the head work for me.
Okay.
All I have to do is basically put the cams in.
Right.
For the 4B11 stuff, we do have to clearance and like shim the heads. And so what I'm trying to say is 4G63s have lifters, hydraulic lifters, right? The 4B11s don't. They have, you know, solid lifters, which are buckets. What you do is you measure the bucket.
Yeah.
Well, you measure the clearance.
Yeah.
And you figure out what you need, and then you put a different bucket in there.
Oh,
That
you
makes
switch the
sense?
bucket itself.
Yeah.
Okay.
I have some.
I see.
I don't know if you can see, but there's a size written on there. There's like a measurement. So you basically have to go in there, you know, with your cams in there with the feeler gauge, go underneath and see if you have the proper clearance, if it's too tight, if it's too loose, and then you shim it like that. But this is our race port with our combustion chamber work, so we polish the combustion chambers as well.
3D.
Yeah, this is actually kind of dirty right now, but you know, once I go over it one more time, it's gonna be ready. It's gonna basically, the whole theory behind this is it doesn't let carbon stick to it. And it's not porous, so if you look at like this 4B11 head right here, right? Oh yeah. You can see the porosity, right? Yep. Right there. So the theory behind that is when the surface is porous like that, or when it's pointy or like has like, you know, deep ridges and stuff. Yeah. So what happens is that causes hot spots. Yeah. Also, you know, not only that, but like let's say like all these like shrouds or whatever right next to the, you know, in the combustion chamber. Yeah. All that stuff is, you know, gonna cause hot spots. Yeah. And so what we do is we polish that and we smooth it down so much to mirror finish, so it doesn't have that anymore. So it doesn't detonate. You know what I mean? So the fuel is more stable in the cylinder. So this takes like 4 or 5 hours to do for all, you know, all 4 chambers.
Oh, wow.
It's a very lengthy process, but you know, the end results are worth it. I mean, you know, when you get like super expensive heads for like domestic cars and stuff, most of them have this treatment done to the chambers. So there's a reason why people go and do it.
Now, when you're porting it, do you have different levels of porting? Like, do you go aggressive on like 1,000 horsepower?
Yeah. Basically, you can open up the actual ports. Yeah. Or you can just clean up the ports with the sanding rolls, right? And like, you see that divider over there? On a stock head, I think I have a stock one that I can show you. Hold on, let me get another head. No, I'm sorry, that's not a stock head.
I don't know if he have anything stock.
No, I do. As you can see, there's a lot of casting flaws because these heads were obviously mass produced.
Yeah.
And Mitsubishi didn't really care about their port flow numbers when they were casting these heads.
They're
you know?
building these to make.
Yeah, I mean any mass produced parts, right?
Right.
I made 850 on a stock cast head, like not ported.
Pretty stock.
Yeah.
Oh, really?
Well, I mean valves and springs
Right,
obviously,
yeah,
but
yeah,
yeah, stock. But obviously, if it's ported, you get a lot of more top end flow.
How much would you get? Would you guess that you gain by porting?
It just depends on how much power you're making in the beginning, like
Right.
what kind of turbo it is.
Yeah.
But like on, let's say like anything 62, 66 and above, probably like 30 to 50 horsepower.
Yeah. That's
In the
a lot.
top end.
Yeah.
You know, you kind of lose in the bottom end because you lose velocity.
Yeah, that was also.
Especially if it's bigger.
Yeah,
the
so
force
like
is
if you have like a stock block,
Sure.
stock turbo, you don't really want to go all out and port it. 'cause
Yeah,
then you lose
you're
the-
not really going to gain anything.
yeah.
I mean, you might gain a little bit, but what you're going to gain, the turbo is going to fall on its face by the time you're at those gains, you know, so you're not going to notice anything on a stock turbo. So I would say like, FP black territory, it's a good idea to start, doing some mild port work.
Right.
And as I was explaining to you, so you see that big divider in the middle, right?
Yeah.
That's really that and the casting flaws, as you see here, like all those bumps and lumps. That's what we try to get rid of, and we try to knife edge that divider that's in the middle.
Right.
So the
Okay,
transition.
So you go all the way down there.
Yes.
Yeah.
So the transition of the air is smoother,
Yeah. I see.
and so you get the air in more efficiently. You're gonna make more power.
Right.
The combustion chamber, as I was talking to you about it, we try to like de-shroud all the stuff. That's a stock head, but you can obviously see that's a lot of carbon, right?
Oh yeah.
Not only does carbon cause like detonation and stuff like that, it also can break off and actually like end up underneath the valve seats.
Yeah.
When the valve closes, if it like slams on a piece of carbon, you can lose compression in that cylinder.
Yeah.
And you can actually like mess up cylinder walls. You can mess up piston rings and stuff like that. So carbon is something you don't want in your motor, especially if it's a race car.
Exactly.
You know what I mean? So that's why we do it.
Yeah, that's actually sometimes people seafoam their car
Yes.
like 200,000 miles, and then all of a sudden you got these carbon deposit flying everywhere, and then the head goes down.
I consider E85 the seafoam of nature.
Yeah, no. Yeah, you'll be surprised how clean the head is when they pour it off on
So-
the E85 car.
And this is this is a more aggressive port because it's a little like enlarged
Yeah.
as well. Obviously the chambers get reworked a little bit. And this is not done yet. Like I said, this is gonna get de-shrouded and all that. And then same thing with the exhaust. You just want to make sure that the divider is smooth so the air's not hitting something, right?
Right. Smooth flow.
Yeah. And that's pretty much it. Yeah, I mean it takes a long time. I like doing porting. It's just like engine building, you spend time on it and you get good results.
Yeah.
But you can't rush it. Anything that you rush, anything engine related where you rush, it's not gonna end really well,
Yeah.
This is off of my car, the one that made 1,000.
Oh, okay.
So this actually lifted at 67 pounds. And this head is done. I mean, I Frankensteined this because it was my own car.
Right.
I knew it was past the service life because these are basically the indicators that, bro, you need to
can't
stop
shave anymore.
machining. As you guys can see, we ignored that many times. So this head actually has the valve seats sunk about 40 thousandths in, just so I have enough piston to valve clearance.
Oh, wow.
So I don't smack them as soon as I start my car.
Yeah.
So in order to do that, I had to notch every single rocker arm. And that's because I had no other option. The car had to go on the dyno the next day,
Oh, wow.
and I had to basically get the thing back together. So
Don't do this at home, guys.
yeah, please don't do this at home. Yeah, I'm never gonna do this again, but
Yeah,
I kind
just
of had to.
in case of emergency.
I mean, it held power until it boost spiked.
What kind of
Alright.
gasket did you use for head gasket?
Okay, so this gasket, this was a custom gasket that I got from Greece. Some of you guys are gonna hate me. So Extreme Tuners.
Oh.
This is Extreme Tuners gasket. So basically, I got their gasket that had the H11 tool steel O-rings, and the rest was just a composite gasket. So it was you're essentially paying for the O-rings. It cost me about $1,000 to get that gasket, which is stupid if you think about it, because all you're paying is the rings, right?
Yeah.
Well, I'll tell you what, man, it held. 50 pounds on a Super 99, no issues. With a head like this, because the problem isn't only that it's shaved down so much. The problem is that there's no meat on here, right? So this meat, this is the soft part of aluminum, right? You see how this one has life?
Yeah.
So if let's say you're having like let's say like you have too much boost in the cylinder, too much timing, right? The head has a tendency to start flexing. It doesn't actually physically lift off. You know, all it's doing is flexing. So if you have a head like this is a virgin head, hasn't been shaved. This has a lot of meat on it. So when it starts to flex, you know, it's kind of like a spring effect with the multi-layer steel, especially the MLS gasket.
Yeah.
So this will actually seal a lot better than this will, because this has literally nothing left on it.
Right.
When this is flexing, it's like a straight piece of metal flexing.
Yeah.
When this is flexing, it's like a shock absorber flexing.
Yeah,
Does that make sense?
Yeah.
So it held 50 pounds, but you know, due to my own greed.
But you knew.
Yeah, I mean,
I'm
I'm not tripping about it. You know, it is what it is. Now I'm gonna get another head and import it and put it on
Which
there.
you bought yesterday, right?
Yes, I bought another head at Mod, so that was a
Yeah.
successful.
Nice.
Yeah, the guy pulled up, it was like a drug deal. You know, he opened this trunk. I was like, I want that head.
Give me how much?
Yeah. Now I'm actually thinking of like talking to a gasket company and see if I can come up with my own little design that I can do. Not the same thing, because I really don't like the composite material. Maybe if we did something with like a copper gasket. Composite is just cheap, man. I don't know. I don't like it. Yeah. And then the only good thing with composite and copper is that it's very forgiving of the finished surface of the machine part. So your block, your cylinder head, it's very forgiving of like how the RA, the smoothness of it. But let's say you were using a multi-layer steel gasket and you had like your mom and pop's machine shop, milled the head, and you can see all the machining marks from the blade or the cutter or whatever you want to call it, right? That's probably not going to seal well.
Yeah.
You know, I mean, maybe 30 pounds, 35 pounds, okay, but when you're trying to get into the big boy territory, it's not really going to seal well, because the MLS is designed to work with the smoothest surface. They give you like a range. Every manufacturer gives you a range, but it's like one of those things, meet or exceed, right? So the smoother it is, the better the MLS will seal. Composite and copper don't care about that. You can have the roughest surface, and because it's softer. It's not a metal. It is a metal, but it's more malleable, is what I'm trying to say. So the copper will actually adhere to the unevenness of the head, or like the unevenness of the block and those ridges and stuff that you have. So far we've learned that 40 over blocks are not good for big boost unless they're fully filled. And you gotta O-ring your stuff if you're trying to make in excess of like 50 pounds of boost, if you're trying to throw that much at it. Also, another thing that people don't understand is ignition timing. It doesn't matter if you have a low compression motor, if you're using the best fuel there is. I mean, I can put Ignite in my car and 20 degrees of timing at the top end, it's gonna lift the head. I don't care what you have. You can have 625 half-inch head studs, it's gonna lift the head, So that's also, tuning is a big factor.
Yeah, of course.